I'm Volker Politz from Semidynamics. I'm the head of global sales. And today we're here in Paris at the RISC-V summit. And obviously we are here to talk to customers and partners and contribute to this event. The All-in-One IP is actually a very high performance implementation of the RISC-V instruction for various use cases, namely the CPU plus the vector and what we call the tensor. What we're doing here this time, I should say, is that we are launching our offering under the heading of Neural Processing Unit, respectively NPU. We call that Cervell, and it's then based on this All-in-One IP. But the key point here is that in a standard NPU offering in the market, there is typically no RISC-V. So what we're doing is we're bringing RISC-V to a new market, and at the same time, we're solving a problem in this market, which is what we call proprietary instruction set, which are invisible to the customer and make them totally dependent on proprietary machine learning compilers. In our case, everything is based on the open ISA of RISC-V. We are using open source libraries to perform the AI functions, and that gives the people a new degree of freedom and security for the future, that they can run future models, AI models on their hardware. NPU heading is really to address this frame of mind of saying, give me a given performance, rather than explain to me how I use a CPU to do it. The effect is actually that we're using a CPU, and in this case, our all-in-one very effective and efficient implementation to make this happen. Since we are a CPU with AI capability, the scaling sort of scale out is we take several of those and treat them like multi-CPU systems under Linux, for instance, as it's standard in the market. The second thing is, because we have parameterized our internals, the details like the vector unit and the tensor, we can also scale up and address the optimized balance for the workload which we're trying to process. For instance, if you're in an edge device, you may have a very compact installation, whereas if you're going to something like a software-defined vehicle, you need more power. And then, of course, the ultimate thing is running very big language model in the data center. So the key point here is that we can easily scale these things. In our Cervell offering, we have a standard offering of up to the 64 TOPS. But of course, we can offer a customized solution to any TOPS or any performance or tokens per second the customer requires by exploiting the scalability of our offering. And the relationship with our customers is really versatile and very custom in a way. So it starts from configuring the IP to their needs in a dialogue, obviously, to the way of helping them get their design done, or helping them, even with, layout and at least PPA or area estimate, running a certain PDK for them in order for them to be able to assess what the final size and the power of the IP. Having said this, we also work very closely on the software side with them. And of course, there is a very big theme called evaluation. So we have on the software side an SDK with simulators, but we also do have an online FPGA access, so they can actually log in, run their own code, and do the evaluation.